Hi guys, now let's check something. I'm going to draw a graph of what? Of distance versus time. Now let's check. Remember, on the x-axis, I will have what? The x value or the independent variable to be what? To be time. It means here, this will be what? This will be time measured in what? In seconds. And then on the y-axis, I will have what? Distance measured in what? In meters. It means distance is a function of what? Of time. Now let's say this graph is what? Is f of what? Let me say d of t, or let me say f of t. F of t, meaning this is a function of time. Distance is a function of what? Of time. Remember something. Let's find the gradient or the rate of change of this function. Remember the gradient or the rate of change? This will be what? F prime of what? F prime of t. Remember we said gradient or rate of change is always equals to what? The first derivative, which is what? F prime of t. This is always equals to what? This is always equals to change in what? Change in y divided by change in what? Change in x. Now let's check. Change in y is measured in what? Change in y is what? Is our distance, of which it is measured in what? In meters. In other words, on my numerator, I'm going to have what? Meters. And then change in x, of which it is time, it is measured in what? In seconds. It means on my denominator, I have second. Now, according to the laws of exponent, remember we have what? We have positive 1. If I take this denominator to the numerator, the exponent will change the sign. In other words, here I'm going to have what? I'm going to have m multiplied by s to the power of what? Of negative 1. In other words, the rate of change or the slope or the gradient of a what? Of a distance versus time graph is what? Is meters per second. And we know in physics that meters per second is always given by what? By velocity. In other words, here, if we are given a distance function, let's say your distance function in terms of what? Distance function in terms of time is equal to, let's say, t squared minus t minus 12. If you are given a distance function, if you want the slope of this function, it means, or the slope or the gradient of this function, you will do what? You will do first derivative and you will get what? Velocity. In other words, the first derivative of distance versus time graph is what? Is velocity. How do we get velocity? Remember, you must derive. In other words, let's say now they ask you, determine what? Determine velocity at time t is equals to what? Is equals to 2. In other words, when now you will do what? You know you are given a distance and velocity is the first derivative of what? Of distance. In other words, you are going to derive what? You are going to derive your function in terms of what? In terms of t. Remember, as I'm deriving the function in terms of t, I will get what? Velocity with respect to t. This is equals to, remember, deriving is all about exponent multiplied by coefficient, exponent minus 1. This is going to be 2 multiplied by 1, which is 2, t to the power of 2 minus 1, which is 1, minus 1, minus 1. Remember, we want the velocity at time is equals to what? 2. In other words, where I see t, I'm going to substitute what? 2. It means velocity at time is equals to 2 seconds. It will be what? 2 multiplied by 2 minus 1, of which this will be what? This will be 3. Now, let's draw velocity versus time graph. Let's draw velocity versus time graph. We are going to draw velocity versus time graph. This will be velocity, which is measured in meters per second. And then this will be time, which is measured in what? In seconds. Now, we are going to find what? Remember, the function is given by what? F of t, or you can say v of what? V of t. Now, let's check something. Let's find the gradient or the slope or the rate of change of this function. This will be what? F prime of what? Of t, or you can say v prime of what? Of t is given by what? Is given by change in y divided by change in x. Now, what is change in y? Remember, change in y is velocity and is measured by what? By meters per second. In other words, here I'm going to have m multiplied by s to the power of negative 1 divided by what? Now, let's check. What is time? Change in x is time, and is measured by seconds. In other words, I'm going to have what? Divided by s. Remember, according to the laws of exponent, I will take s to the numerator. The exponent will change the sign. It means here I'm going to have m multiplied by s to the power of what? Of -2. Remember, according to the physics, what is meters per second squared? Meters per second squared is what is given by acceleration. It means, my friend, if you are given a function of velocity versus time, or a function of velocity with respect to time, and you want acceleration, it means you must derive what? You must derive your velocity function with respect to what? To time. Let's make an example. Let's say we are given what? We are given v of t is equals to what? Is equals to t squared minus what? Minus t minus 12. And they say to you, determine acceleration at time is equals to what? At t is equals to 2, or after 2 seconds. Determine the acceleration after 2 seconds, and you are given what? A velocity function. Remember, you must derive in order to get what? Acceleration. This will be what? V prime of what? Of t is equals to what? 2t minus what? Minus 1. Remember, we want the acceleration after what? After 2 seconds. In other words, where I see t, I'm going to substitute what? 2 minus 1. This is going to be 4 meters per second squared. Remember, now let's check something. It means, if I'm given what? It means acceleration is the first derivative of velocity function. But remember, velocity function is the first derivative of what? Of distance function. It means now automatically acceleration will be what? Will be the second derivative of distance function. Now let's check what we are talking about. Remember, if we are given a distance function, d prime of t is always equals to what? Velocity. And then if we are given what? Velocity function, v prime of t is always equals to what? Acceleration with respect to what? To t. Are we fine? In other words, here it means now acceleration will always be equals to what? D double prime of what? Of t. If you are given a distance function graph, it means now in order for you to get acceleration, you must derive your function twice. Now let's draw what? Let's draw momentum versus time graph. Remember, momentum is measured in kg multiplied by meters per second, because momentum is always equals to mass multiplied by what? By velocity. This will be momentum. Yeah, this will be what? Time measured in what? In seconds. Now let's check. Our graph is a function of what? Let's say momentum with respect to what? To time. Let's say this can be equals to f of what? F of t. Now let's check the slope or the gradient or the rate of change of this function. It means this will be what? F prime of t, which is equals to m prime of t, which is equals to what? Which is equals to change in y divided by change in what? Change in x. This is always equals to, remember, change in y is measured in what? In kg meters per second. This will be kg meters per second divided by what? By s. Now let's check something. It means now this will be equals to what? Kg meters per second to the power of -1. Remember, you are going to take this s to the numerator, multiply by s to the power of -1. This will be equals to kg meters per second squared. Remember, this will, kg is mass, meters per second squared is what? Is acceleration. And we know that F net, the resultant force, is equals to what? Mass multiplied by what? By acceleration, of which it is this unit, kg multiplied by what? By meters per second squared, of which it was, it is what? It is mass multiplied by what? By acceleration. In other words, the rate of change of what? Of momentum with respect to time is always equals to what? The resultant force. Thank you very much for today's session.